All right, welcome back, everybody. Hey, you want to hear more about how p-vectors are amazing? Like, have I not sold you on them yet? Then stay here. Keep watching. We're gonna make our target into a bouncy ball, and it's really easy with p-vectors. It's so easy, and I think if you haven't been sold yet, then maybe this will convince you. So what I like to do is add in some kind of gravity that's a force that's constantly pulling us down. And as you might remember from physics, Sir Isaac Newton, his laws, three laws, there's one that's like F net, the net sum of all the forces is equal to mass times acceleration, right? So we're not going to take into account mass, so this isn't really true physics. But, essentially, forces, it says F net equals ma. Like forces are proportional to accelerations. They're combined. With the mass, like really forces are momentums is probably a best way to phrase it. But without getting into all the math, you can approximate forces with accelerations. So what are accelerations? Well, they're just changes in velocities, right? An acceleration, if you accelerate your car, you're increasing the speed. If you decelerate your car, you're going slower. So forces can be thought of as accelerations in a simplified massless environment. If all the masses were equal to one, then forces would be accelerations. So that's our case. We have a kind of massless space. So let's look at how we could approximate the force of gravity inside of our little target clicker game. So I'm going to make a p vector. I'm going to call it gravity. Okay, so gravity is going to be a force, which is really just an arrow that's going to point down to the bottom of the screen. So when I go to make gravity, I'll say gravity equals new p vector. And you can choose the strength of your gravity. I'm just going to make it 1 comma 0. That is going to mean, oh no, that's not right. 0 comma 1. This is y, x, y. So that means 1. Here's the upside down y-axis. Positive means down. So we have a force that is pointing down. We haven't, well, honestly, right now we have an arrow that's pointing down. What changes gravity to become a force, though? Or an acceleration, if you will? So remember the definition of acceleration is just a change in velocity. So if I go over to our programming here, location.add velocity, that's how we're changing location. That's what turns this into a velocity, right? A velocity is a change in location. So if we want to make an acceleration, we can change velocity with it, right? Velocity.add gravity. And that's what is the definition of an acceleration, right? So that's just going to work. And you're just constantly changing velocity by adding that arrow onto it, and it will gradually kind of force it to go down. And by gradual, I mean over the course of many frames. And since we see so many frames, it just all kind of comes together. Let's run it and see it in action. So we'll start the clicker game. And do you see that? This looks so realistic. It's just falling and bouncing. We see that kind of parabolic motion that we would expect to see. The bouncing is like accelerating though. Look at that. It's like getting faster and faster. So we got some work to do. It's not perfect. It's like the bouncing is more than elastic, like in physics, that elastic collisions and so on is like more than perfect elastic. It's extra. So let's go and think, oh my gosh, he's gone into the universe. It's escaped. So let's go and change that. So one thing I noticed that, our collisions perfectly keep the value right when it collides with the ground. So instead of like being like just negative velocity, let's be like negative 0.9 times velocity, something like that. Like this will mean that it'll lose some of its velocity. It won't just immediately port over and just like flip around. It'll only be 90%. And that actually will be like a pretty steep drop off, I think. Let's find out. So here we go. So now we're bouncing and it's like slowly coming to a halt and will eventually just kind of lie still. And that's looking pretty good. We still have like perfect collisions on the left and right wall, so we could probably do something similar. So we could, take that and put it down here so that it also doesn't like roll back and forth endlessly. And then here's our ball, just kind of coming to a halt and bouncing. So, man, that was so easy, right? With vectors, we just made a vector, which was a direction, and by adding it to our velocity, um, we we just instantly created a force. And we can do a ton with this, right? Like we could change my original mistake. Like what if I made that our gravity? Like then it would bounce on this wall. Oh, things got a little wild there. Like it can now like crash along a different one. We can alter gravity. We can make gravity go in all sorts of directions. We can use rotate to change the direction of gravity. We can make all sorts of interesting things happen with forces. So this is why we're doing p-vectors. They provide us with some new tools that are powerful, and they're not really that different than what we were doing before, but they are powerful. So, anyways, if I haven't convinced you, then you keep talking to me, and I'll keep doing my best. If I haven't convinced you, I'll shut up now, and we'll go and make some asteroids. Okay? Thanks, everybody. Take care.